So we're on page 19 now, talking about reflection. And this is something that's not foreign to us. It's not brand new topic. Okay. But on the book, they have their own section. So let's talk about this. There's going to be something that's going to be a little bit different today that we will discuss when we go to lesson 5, which is reflection over the line y equals to x. So that's something that's brand new though. So let's take a look at this. A function can be reflected in, okay? Sometimes we use the word in, sometimes we use over, sometimes we use above, okay? So we have different kind of propositions for which one is your line of reflection. So reflected in the x-axis, but we know what that means. So over the x-axis and the y-axis, or the line that's y equals to x. This one is brand new. These two, not brand new. So note that the reflection in the y-axis results in the change of the sign in the x-coordinate of a point, and the reflection in the x-axis, the change in the sign of the y-coordinate of a point. The y-coordinate of a point. So let's take a look at this one here. So given the graph of the function shown below, so we have this image, sketch the image graph after reflection in or over the y-axis. Okay. The reflection in the y-axis. So this is the y-axis. Where is it going to be reflected? This way, right? Okay. So, I mean, we're so good at doing the mapping, the point mapping. We could certainly do that. Okay. That's something that we're really, really familiar with. So what are the key points? Red, you have a few. You have a negative 1, 1. We have a 1, negative 5. We have this point right here. It's going to be 5, negative 5. And then finally, let's take this one here. It's going to be 9, positive 3. Now, because this is a reflection over or in the y-axis, we're actually changing, we're reflecting the x, right? So it's going to be negative x, comma, y. Okay, so let's do that. Go ahead and try that, and then I'll do the same. Okay. So, let's graph the new graph. Go ahead. You can graph your graph now. I'll do the same. So does your graph kind of look like this? Yeah, okay. So this is your f of x, and then this is going to be the negative x, f of negative x. Let's take a look at the domain and range. Oh, but before I move on to the domain and range, did your graph kind of look like this? Or exactly like this? Let's do the domain. Yeah, we're going to do the domain and the range of both original and then the image. So the domain of this is going to be from -1 to +9. So -1, comma 9. Okay. And then the range is from -5 to +3. -5, comma +3. So far so good. Now, what is the domain and range of the image? The reverse. Excellent. I was just gonna say, what's a relationship between the two of them? It becomes, now it's at -9 to +1, right? So it's like a reverse opposite of this, which makes sense to us because we multiplied every x value with -1, so it does make sense. So it's going to be, this one's, we have to start with -9, -9, comma, +1. Right? Because we always start from small to big. What about the range? Did it change at all? No, no change. So it's going to be -5, comma, 3. Very nice. Good, right? So when we reflected over the y-axis, the x changes to its opposite. The only thing that's changing here is the domain, but not the range. Good? Pretty straightforward. Let's take a look at B. Given the graph of the function below, so it's exactly same picture to begin with, but in this case, it's a reflection in the x-axis, or sometimes we call over the x-axis. So if this is the x-axis right there, and if you want to reflect it in that or over that, in our case, in and over means the same thing, what would be changing? So let's do the x comma y, and then because it's reflected to the opposite y, it's going to be x comma -y. Okay. So go ahead and give it a try. Okay, does your graph kind of resemble the one that I have at the front? Yes? Okay, that's good. So it's a reflection over the x-axis, so that means the y changes, the x stays the same. Let's do the domain and range. Domain is from -1, 9. The range, -5 to 3. Now, what's the relationship now between the domain and range of the original to the domain and range of the image?
Domain stays the same, but the range is the reverse.
Yeah, it's opposite, right? Yeah, good. So now the domain stays the same. It's -1, 9, but the range, every point on the range, every y coordinate is multiplied by -1. So now it's going to be -3, 5. Yeah, makes sense? Now we take a look at this. Did the shape change? No? But the shape of the original graph is congruent. It's exactly the same. We did not compress it. The only thing what we did was reflected it. Okay. Any questions there? So far, so good. Okay. Now let's take a look. So this one, example number 3, is a specific function, not a graph, but a specific function. So here, what is the equation of the image when the graph is root of x plus 5 and it's reflected in the y-axis? So reflected in the y-axis means, okay, which one is the negative? X would be the negative. So that would be y equals to square root of -x plus 5.
And in that circumstance, would the +5 have to be moved to the opposite side to be negative?
Yeah, you could do that, or you can just leave it like that. Now there's like, is there something in you that's kind of like saying, is it okay to have a negative? I thought when we take a square root of a number, it should be positive, right? Is that what you're thinking about? Kind of, no, okay. So when you look at this part is negative, this is x. So what will make the whole thing positive? Negative x values. If your x values are negative, okay, so think of a negative, -4, you go -4. That will give us a +4. Okay, so it's okay that you're probably thinking, I thought we can't have a negative. Yes, we can. It's just the values of the x will be negative. So when we have a negative times a negative, will give us a positive. Okay, good. Let's take a look at this one. What is the equation of the image when the graph of y equals to absolute value of x minus 3 is reflected in the x-axis? So, or over the x-axis. It's going to be y equals to, what's the value? Negative absolute value of x minus 3 so the a value is changing. The a is the one that's changing. It's going to be negative absolute value of x minus 3. Can you go like this? So So you can say, okay, so that's a good idea. Okay, like we'll go here. We can go negative y equals to absolute value of x minus 3. That's a possibility too. But if you want to solve for y or have y alone, you would divide by negative 1, right? So yeah, they're the same thing. I'll do it. If I divide by negative 1 to have the y alone, you're going to have y equals to negative 1 or negative absolute value x minus 3. So it's the same thing. You can take that or have it like this. Is that okay? Yeah, that's a good point. Okay, let's take a look at the letter C. Write an equation of the image of the function g of x, where it's negative 4x squared plus 3x minus 7, if it is reflected in the x-axis. Reflected in the x-axis, so the y changes. I like the thing that one of your colleagues had said earlier. Okay, so g of x is this. So it's going to be y equals to negative of all of that. Your a value is going to be negative. So that keeps it as negative 4x squared plus 3x minus 7. If we simplify that a bit more, then you just do the distributive property of multiplication to multiply in the negative 1 or the negative. It's going to be 4x squared minus 3x plus 7. What about this? Reflected in the y-axis. Reflected in the y-axis. So that means it's going to be y equals to the g of negative x. So x is negative. So how does that look now? Y equals to negative 4 times negative x squared. Okay, so far so good. So we're substituting negative x wherever we found the x, plus 3 times negative x minus 7. Simplify this thing. So this is going to be negative x all squared. So that makes it positive 1x squared, times it by negative 4. So that still stays at negative 4x squared minus 3x minus 7. So this is the reflection piece. Let's put a note here on the side here, because we always want to connect what we're learning to something that we already know, right? And something that we already know is that y equals to a f of x. So here, the reflection on the x-axis, the a must be negative 1. So negative 1 times f of x. So this is something that we already know from the previous topics. What about this one here? Reflected onto the y-axis or over the y-axis. So that becomes y equals to f of negative x. So x is negative. Did we substitute negative? Negative 1. Negative 1. I'll write it better. There you go. So you substitute negative or negative 1x wherever you find the x. Is that okay? Let's take a look at this. Now this one here kind of gives us a domain and range. Domain and range. So what would happen if we have y equals to negative f of x? What's happening in here? This is a reflection over what?
X.
Okay, so the negative, so is this reflection over the x-axis or the y-axis? The y-axis, okay. So reflection over y, no, reflection over x-axis. So that means the y is changing to its opposite, right? So y is changing it to its opposite. So initial domain is from, original domain is from 3 to 12. The range is from negative 9 to 2. So if this is a reflection over the x-axis, sometimes I like to draw a picture myself. Used to be over here, reflection over the x-axis, that's over there. Right? So that means y changes. I'm gonna actually, so reflection over the x-axis. So y changes. What's the new domain and what's their new range? Domain stays the same, right? It's going to be still 3 to 12. And then the new range, negative 2 to positive 9. Correct. Is everybody okay with that? Okay. What about this one? If it's inside the brackets, what does that mean? Yeah, it's a reflection over over the y-axis. Okay, over the y-axis. So the old domain is from 3 to 12. The range is from negative 9 to 2. Okay, what's the domain of the new image? Negative 12 to negative 3, because everything on the x, see here, negative on the negative, everything on the x is being multiplied by negative here. You see that? Everything on the x is being multiplied by negative. So these are all the x's, 3 to 12. So if you multiply everything here by negative, this becomes negative 3, this becomes negative 12. But we want to make sure that we write it from smallest to big. So start with the negative 12 to, what's the new range? The same as the original, right? Good. Okay, reflection over. I forgot to put the X here. I'm pretty sure you put that in already. X-axis. Okay, I'm gonna go back to this one. Negative is multiplied with f of x. Well, what's f of x again? Those are the y values, right? So all of the y values that I have in here got multiplied by -1. So all of my y values got multiplied by -1 in here. Imagine, if multiplied by -1, that becomes +9. Multiplied by -1, that becomes a -2. Okay, but we just want to write it properly from smallest to biggest. It's all good? Okay. There are some practice questions in here. I'm going to stop this YouTube video, and of course, I'm going to give you maybe about 10 minutes to work on some of these questions. It's not quite a lot. Give you that time. And then later, we're going to double up, okay? We're going to double up on this one, inverse of relations. Good.